Hello, and welcome to Saturday Science from the Public Libraries of Saginaw. My name is Michael, and how this works is, during the week this summer, you can pick up Saturday Science kits at Zoll Library in Saginaw Township, and then on Saturday, we'll post a video with instructions on our YouTube and Facebook pages. Just search for the Public Libraries of Saginaw on YouTube or Facebook, look for Saturday Science, and follow along with the instructions. In this program, we encourage kids to build, play, get messy, and explore the world around them with these simple science experiments. One last note is that we will have a limited supply of kits available, so I encourage you all to call Zoll ahead of time and make sure kits are still available. Today's Saturday Science project is to make homemade bubbles, and it's actually very simple, but the science is interesting. So let's talk about the science first, and then we'll make the bubble solution. So bubble is just soap film wrapped around air. Soap film is made from soap and water. A bubble is made of 3 layers. So the soap film, if you zoom in close, looks like a sandwich with soap as the bread on the outside and water as the filling on the inside. So let's zoom in close and see what we're actually looking at on a micro level. So here we are zoomed in close to the surface of a soap bubble. And as you can see, we have soap molecules on the outside and water on the inside. So let's go ahead and zoom in on an even closer level. Now, as we know, the world around us is made of atoms. Atoms are made of extremely tiny particles called protons, neutrons, and electrons. And when 2 or more atoms link up, they create a molecule. Soap molecules have 2 ends, a hydrophobic end and a hydrophilic end. The hydrophobic end avoids water and attaches to oil. The hydrophilic end avoids oil and attaches to water. It's almost like a magnet, how you have opposite sides, the positive and the negative charges. Soap thus helps attach oily dirt to water so the dirt can be washed away from clothes and dishes. So this is just a little diagram of sort of the hydrophobic and the hydrophilic ends of the molecule. And as you can see, it then sort of traps the soil, the dirty molecule, and then makes it available to kind of be washed away. And when we talk about bubbles, we also want to talk about surface tension. Now, surface tension is the force between liquid molecules at the surface. So in this case, we're looking at water. The water molecules cling to each other so tightly, and it causes the surface of the water to behave like an elastic sheet. Now, elastic substances tend to return to their original shape when they're stretched out. So it's almost like a skin. And water doesn't make free-floating bubbles all by itself. As you know, if you blow a bubble in water, it pops quickly because the surface tension of the water is relatively high, and water is not very stretchy. Adding soap decreases the surface tension so that the water can stay stretched around the bubble. Now, as a bubble is blown up larger or is stretched in other ways, soap stabilizes bubbles by an action known as the Marangoni effect. In places where the bubble is stretched, the surface concentration of soap decreases, and it causes the surface tension to increase. And this area of increased tension springs back to its original form and prevents the bubbles from stretching to the point of popping. So this all sounds very scientific, but basically this means that the result is a bubble is always the same shape when you blow it, a sphere, because it has the same surface tension all around. And that's because deforming a bubble takes energy. A bubble tends to spring back to the shape that is stretched as little as possible, which is the minimum surface. So floating around in the air, a bubble will become a sphere because a sphere has the least surface area for a volume of air. Another way to think about this is that the bubble is stretched most evenly as a sphere as compared to something like an egg shape or a cube. A shape with corners or edges means that the soap is stretched unevenly. So let's go ahead and get started with the actual bubble solution. So actually making the bubble solution is really the easy part of this experiment. Now that we know a little bit around the science of bubbles, all you have to do is, for this recipe, we are combining sugar, water, and soap. So what you're going to want to do is get about 3 to 4 cups of warm water, and you're going to put it in a bowl, and then you're going to stir in the ½ cup of sugar and until it dissolves. So let's go ahead and do that. So it may take a minute or two to let the sugar dissolve in the warm water. You can kind of look, if you have a clear bowl, at the bottom of the bowl to get a gauge on how dissolved the sugar is. Okay, now we're going to add the ½ cup of dish soap. And I'm going to stir that for a minute or two. Now, one thing to note is if you let this solution sit on the counter for a few hours or even a day, it seems to work a little bit better the longer you have it sit out. So your bubbles may not work as well if you try and blow them immediately from the solution, but we'll try that out with this. I made a different solution the other day, and it worked, but it worked a little better after I just left the solution on the counter for a couple hours. So you can also try different solutions, different soaps. You can try less water. So if it doesn't quite work out, you might want to tweak the recipe a little bit and see what does work for you. But that's the basic components. And for my wand, bubble wand, I just am using a simple pipe cleaner. So if you have one laying around, perfect. If not, you can kind of create one. So there is a film there. Yeah, I think this will work. There we go. And the sugar basically helps the water and soap solution become a little more viscous. It just helps the soap kind of bind together a little stronger. And so that's why we added the sugar. But this is a great mixture to go out and play this summer. I hope you enjoyed today's Saturday Science, and we will see you next week.